Let us see the first question. When there is no restriction, okay, so there is no condition at all, it is free and it says what is to be done. Let us see. So when they say when there is no conditions, you are supposed to not consider any of the extra conditions and just read the question and apply the normal permutation. Okay, so the word monkey has 6 letters. Okay, the first number, find the number of words that can be formed by using all the letters of the word monkey. Okay, so they've given us one word called monkey, and how many alphabets are there? 1, 2, 3, 4, 5, 6. Okay, so there are 6 alphabets here. Correct, Imran. So there are 6 alphabets here, and they're asking us how many words can I form or can we form using this word monkey. Okay, so here let's say I have key, I have, let's say I have money. I can form money, MONEY. I'll take out key, K here. Okay, so like this, if I form the words, and there is no restriction on number of words. Okay, there is no restrictions on number of words, but I totally have 6 words. Using the 6 words, how many words can I form? Now since I have 6 words in monkey, the simple calculation is 6 words are there, and out of 6 words I take all the 6 words to form the words. Sorry, it's not words. Okay, I have 6 words, I take all the 6 words to form the words. So 6p6 is nothing but 6 factorial. Okay, 6p6 is nothing but 6 factorial. So I have 6 factorial ways, or if you solve 6 factorial, that is 6 into 5 into 4 into 3 into 2 into 1. If I solve this completely, I get 720 ways. So using a 6-letter word monkey, I will be able to form 720 other words. It may be 3-letter word, 2 letters word, 5-letter word, 6-letter word. Okay, I'll start from 2-letter words. Okay, so let's say something like on. On is one, right? Similarly, that was just one example. Okay, I can start from 2-letter words, and then 3-letter words, 4-letter words, 5-letter words, and 6-letter words. So in 720 ways I can form the number of words by using the word monkey. Understood? Did you all understand? Any doubts in this problem? Can we go for the next type? Very simple, no restrictions. How whatever data is given, just check the number of options and then how much you are supposed to select. Here we are selecting whole of 6, which is nothing but 6 factorial, that is 720 ways. Simple. Okay, let's go to the next type. When all the words begin or end with a particular letter. Now first case we saw a word monkey was given, and from that we found the words. Now coming to the next type is when all the words begin or end with particular letters. Now if I say I want letters starting from A, okay, I want letters starting from let's say D. So, and I want letters ending with S. I want letters ending with U. Now, if I give certain conditions like this, then they come under this category. So, let us see how to solve such problems. Okay. Find the number of words that can be formed by using all the letters of the word rainbow. So firstly, the focus should be on the word. So what are they asking? Find the number of words that can be formed by using all the letters of the word rainbow. So we are supposed to find the number of words where we are using all the letters of the word rainbow. So rainbow, RAIN, 4 BOW. So 1, 2, 3, 4, 5, 6, 7. We have 7 letters in the word rainbow. Now, if we are using all the 7 letters, and if we are finding, or if we are forming the words, then which means I have 7 letters in rainbow, wherein I am going to use all the 7 letters to form the words, which is nothing but 7 factorial. Correct? Which is nothing but 7 factorial. Did you all understand until here? So we are finding the number of words that can be formed by using all the letters in the rainbow. Okay, this first sentence is similar to the first case where we solved without any restrictions. Okay, so 7 factorial. So the answer for this is, find out what is the value of 7 factorial. Can somebody do it quickly? 7 into 6 into 5 into 4 into 3 into 2 into 1. 5040. Good. So we will be able to find 5040 words using all the letters in the word rainbow. Clear? Understood? Okay. Now this was for only first question. Now let us get into the sub questions given to us. Okay. How many of them begin with R and end with W? So out of 5040 words, how many words will have the starting letter as R and the ending letter as W? Okay, so let us check that. Now in this case, what will happen? We are gonna keep R and W fixed for the place. Now in this rainbow, R AINBOW. Okay, so what are they asking us to find? How many words, how many of them begin with R and end with W? So in between you can have any words. In between you can have any words, but the starting word is supposed to be R and the ending word is supposed to be W. Okay, so this is the only major condition. Now R is fixed, W is fixed. How many more spaces are left out? 1, 2, 3, 4, 5. 5 places are left out. Now I have 5 places to be filled, and apart from R, I have how many more letters? A, I, N, B, O. I have 5 letters. I have 5 letters with me, and I have 5 empty spaces with me where I can fill the letters. So, which is nothing but, can I say I have 5 factorial ways to arrange these words in this place. I'll repeat. Can I say I have 5 factorial ways to arrange these letters in this place? Yes? Did you all understand? Everybody understood? Okay. So what will be the answer for this? 5 factorial ways is nothing but 5 into 4 into 3 into 2 into 1. So that is 120 ways. So I have 120 ways to arrange 5 letters in these 5 places. So my words will start with R and it will end with W. In between, I can jumble the whatever letters are available to me, and I can do that in 120 ways. Clear? See, here I've given the explanation which all letters are kept separate. R is fixed and W is fixed. Okay, the place of R and W is fixed. In between, whatever we have, only for that we are supposed to take the permutation. The circled letters will not be considered. Which are the circled letters? R and W are circled letters. So we have fixed that, and rest we are trying to take it here and there. Can we go for the next sub question? Clear with this, right? Okay. Next, how many of them end with BOW? Okay. So last 3 letters is supposed to be BOW. Okay. Let's go to the next sheet. Okay. How many of them are ending with how many of them are ending with BOW? Okay. So my last 3 places are fixed. Last 3 places are fixed. Now, before that, how many more places I had? 1, 2, 3, 4. Correct? Now, last 3 places are fixed and 4 places are left blank. Okay. So, for how many letters are there in rainbow? There are 7 letters in rainbow. Out of that, 3 letters are fixed. So I have 4 more letters remaining. Okay. So I have 4 letters wherein I am supposed to fill 4 places. So which is nothing but 4 factorial ways. And I have 24 ways to fill these 4 places with 4 letters, that is RAIN. Everybody understood? Good. Many of them have given the answers. Good. Everybody understood this? Words ending with BOW? Okay. Now let us go to the next sub question. So my next sub question is very similar, but here instead of last letters, they have given us the starting letters. So let us see what is that. Words beginning with ROW. Okay. So first 3 letters will be ROW. Now after ROW, I still have how many more letters left over? In rainbow, there are 7 letters. Out of that, 3 letters are ROW. I still have 4 places left to be filled. Now, apart from ROW, which are the other letters left over? A, I, N, B. I have 4 letters left over. So 4 letters are available for 4 places, which is nothing but 4 factorial. Again, we have 24 ways of arranging A, I, N, B in this place. Clear? Everybody understood? Okay. So we saw two types under alphabets. The first type was without any restrictions. The next type is when all the words begin or end with particular letters. Okay. So here first we found out the number of words that can be formed by using all the letters of the word, and then in sub questions we understood how to calculate the words beginning with R and ending with W. So R and W were fixed, in between we can jumble the words. Next sub question, the last three words were fixed, so the first four words we could jumble up. And then for C, how many of them will begin in a row, which means the first three letters were fixed and the next four letters we could jumble up. Okay, so this was the case 2. Now can we go for the next type of problem? Okay. The next type of problem is when few vowels, letters or consonants are given together. Now you all know what are letters. Yes, everybody knows what are letters, right? Now what are vowels? What are vowels? What all can I constitute as vowels? A, E, I, O, U. Okay, so these are vowels. And what are consonants? What are consonants? Yeah, vowels are A, E, I, O, U. There are 5 vowels. And what are consonants? Good, good. So except A, E, I, O, U, the remaining letters of the English alphabet are called as consonants. Okay, so first you have to be clear with these two concepts. So vowels are A, E, I, O, U, and leftover except A, E, I, O, U, whatever other letters are there, the other 21 letters are called as consonants. Okay, so here what are they saying? When few letters, vowels, consonants occur together, okay, when they come together and or when they are supposed to be together, how are we going to solve the problem? Okay, so let us check the question and then we will be able to understand. In how many ways can the letters of the word laughter be arranged so that vowels are always together? Okay. Okay, Rida has tried something. Okay, good, Rida. We will see how it is to be done. Okay, now we have the word laughter. Now in this word laughter, can you say me how many vowels are there? A is a vowel, U, E. So there are 3 vowels. A, U and E are available for us. So these are 3 vowels. Then apart from vowels, what are the other? Okay, which are the other consonants left out? L, G, H, T, R. So consonants are 5. Yeah, E is not there, Bindushri. E is a vowel, my dear. Okay, so we have 3 vowels and 5 consonants. Now, what are they saying us? We have to arrange this word in such a way that, okay, we have to arrange this word in such a way that vowels are always together. Okay, vowels are always together, which means whichever word comes, these 3 vowels are supposed to be together. So I'm going to make this vowels as one unit, because it says vowels are always together, so I make them as one unit. Okay, now apart from 3 vowels, I have 5 consonants. So in how many ways can I arrange the letters? 5 consonants are there, so 5 ways, plus vowels are supposed to be together always, so I take them as one unit. So 5 plus 1 is equal to 6. I have 6 separate units here. Okay, so when I have 6 units, can I go for 6 factorial ways? If you remember this, this is something like the number of books. Yeah, correct, Rida. Okay, this is something like number of books of maths, stats, and accounts that we had. So we were supposed to keep maths, 7 books of maths always together. Okay, so we consider that as one unit. This is similar to that, but here we are using the letters, vowels, and consonants. So these 3 vowels are always together, so I consider them as one unit. I have 5 consonants, so 5 plus 1 is 6. So it is 6 factorial ways. But one more point is, now this one unit is nothing but 3 vowels. Now this 3 vowels also I can arrange them in between. I can write it as A, U, E, or U, A, E, or E, U, A. Like this I can give varieties for the 3 vowels also. So which means for the 3 vowels also I can arrange them in 3 factorial ways. Okay, I can arrange them in 3 factorial ways. So first, listen carefully, I'm summarizing the whole problem. Yeah, correct. So first, what did we do? We arranged this letter, or we understood that in this word laughter there are 3 vowels. Okay, in this word laughter there are 3 vowels and 5 consonants. Okay, there are 3 vowels and 5 consonants. Now when it comes to the vowels, they told it has supposed to be always together, so I consider them as one unit. And then I have 5 consonants, so 5 plus 1 6, so I can arrange them in 6 factorial ways. Along with that, I have 3 vowels, which is one unit. So these 3 vowels also can be arranged in different ways. So I add them, or I consider them as 3 factorial ways. So the total words that I can form, okay, the total words that I can form is 6 factorial into 3 factorial. So please find out what is 6 factorial. You will get the value as 720, and 3 factorial is nothing but 3 2s are 6. So the total number of ways a letter of a word can be arranged where the vowels are together are 4320 ways. Okay, so I can arrange 4000 in 4320 ways. The word laughter can be arranged wherein this 3 letters will always be together. Understood? Clear? Everybody understood? We'll go for one last type of problem for today. Okay, this is also easy. Are you finding it easy? Are you finding the problems easy? Okay. We will solve more number of problems again. These are only like type headings. Under them, we will, apart from these type heading problems, we will solve few more problems. Okay. Now, when vowels and consonants occupy odd and even places. Now, let's say we have a 4-letter word. Okay, so we have a 4-letter word. Now, in this 4-letter word, 1, 2, 3, 4. Okay, now in such questions, what is that they will be asking is, they will keep either odd words fixed or they'll keep either even words fixed. Even words are the second, sorry, even letters. Okay, so the second letter and the fourth letter, sixth letter, eighth letter, like that, they will keep it fixed, or they will give a condition for an even letter, or they'll give a condition for a odd letter. Okay, so that is why when vowels and consonants occupy even and odd places. So let us see the question to understand it better. In how many ways can the letters of the word hexagon be arranged so that the vowels are always in even places? Okay, firstly, let us recognize how many vowels are there in hexagon. Okay, we have E, we have A, and there is O. Correct? 3 vowels, E, A, and O. We have 3 vowels. And how many consonants are there? H, X, G, N. 4 consonants. So H, X, G, N are 4 consonants. Now we are supposed to find out how many ways can we form the letter by using hexagon, wherein the vowels occupy the even places. Now if you see here, hexagon is a 7-letter word. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, this is 7. So 1, 2, 3, 4, 5, 6, 7. Okay, now in this 7 places, how many even places are there? How many even places are there? 2 is a even place, 4 is a even place, 6 is a even place. Okay, so we have 3 even places and we have 3 vowels. So they are saying us vowels are supposed to be in the even places only. So there are 3 even places and there are 3 letters. So we have 3 places in the options and we also have 3 letters with us, which is nothing but 3 factorial ways. Understood? Understood the first part? I'll repeat it once again. Listen carefully. We have the word hexagon. In this, we have 3 vowels. They're asking us to find the number of ways where we can place this 3 vowels in the even places. Now, in the word, in a 7-letter word of hexagon, okay, so there are 3 even places, that is 2, 4, and 6th place are the 3 even places. So I have 3 place and I have 3 alphabets or 3 letters. So I can arrange them in 3 factorial ways. Okay. Now, apart from the vowels, I have 4 consonants, that is nothing but H, X, G, and N. Okay. I have 4 consonants where I am supposed to put them into the other 4 places remaining. 1, 3, 5, 7. The odd places will be filled by the consonants. So I have 4 places and I have 4 letters. So which is nothing but 4p4, which is 4 factorial. So the total number of ways I can arrange the letter word hexagon is 3 factorial ways for vowels and into 4 factorial ways for consonants. Okay, 3 factorial ways for vowels and 4 factorial ways for consonants. Clear? Now if you find the factorial for this, now let us try and find the factorial for this. 3 factorial is 3 into 2. 3 factorial is 6. Then 4 factorial. 4 3s are 12, 12 2s are 24, 24 1s are 24. So 6 into 24 is 144. So I have 144 ways where I can arrange the word hexagon so that the vowels are in the even place. Okay, so I have 144 ways where I can arrange the word hexagon and the vowels are in the even place. Clear? Understood? Any doubts until here? Okay. Fine. So we shall stop here and continue in the next class.